All right, welcome back. I hope you're enjoying the show so far. Our next speaker is Edward Turner. He is a machine learning engineer at Levi Strauss & Co. Please join me in welcoming Edward to our virtual stage.
Hi, thank you. Machine learning model production deployment. So part of our agenda today is going to discuss and consider the three different cycles that is normally part of the entire model and data and AI components. And then we're going to look into some serving style agnostic deployments. And then we're going to consider some case studies. So first is the three life cycles. The first one to consider is this, what's called the software development life cycle. Now this only revolves around the code, the software you're developing that's going to represent the system for your machine learning models. And so typically, as you can see, there's a planning aspect, there is a analysis aspect, then there's going to be design, where you're designing now essentially the infrastructure. So if you're doing object-oriented programming, this is what you do. If you're doing functional programming, this is what you do. And so you design there. And then you implement, making sure things matches your criteria. And then you have your testings and integrations, where now you're putting into your, say, your cloud environments, or maybe your on-premises environments. And then you're going to have maintenance. And maintenance is going to essentially revolve around the ideas of bug fixes and adding new features. And this could be deploying a new model. This could be adding new features to your overall training sets. And so this is normally the very first cycle that we're familiar with, and one cycle that we actually always encourage from a machine learning engineering point of view. But then we also have the data science life cycle. Right, now this is the second one. So here it's a little different. They're slightly similar to the software development lifecycle, but it's a little different. So you see here we got the business understanding, where this is normally where your data scientists interact with business stakeholders to solve problems at scale. Then you're going to have data mining, which is now going to look towards, after you analyze the problems that you have, you derive maybe some type of way to solve that problem. Then you look to see what data you have available, so you start looking for it. And then you have your data cleaning, just to make sure that you have everything in place. You remove all the different aspects that could be an impediment to your overall model training. Then you're going to have your data exploration. Then you're going to have your feature engineering, your predictive modeling, and then your data visualization. And some of these are interconnected. You know, again, it's a life cycle, so you kind of go out of one, say, a section of the circle, and you might jump into another one. But a lot of times, this is the normal pathway, the 1 through 7. And now you also have your machine learning model life cycle. Now, this is going to be a little different. We're going to talk about the differences between all three. But this is a little interesting, because this actually refers to the model that you just trained. And so you're going to develop your model. You're going to want to deploy that model. And then you want to monitor, get some feedback from that model. And then that feedback could lead to a model development, which could lead back into more experimentation and collaboration. But this loop here could actually be closed, and we're going to talk about that. Now, we're going to have essentially, as I mentioned, not all of them are the same. There are differences. Now, this is just more or less not an exhaustive list, but these are a lot of the main points here that's going to be different between each of these three. The software development lifecycle, which is the SDLC, a lot of time just revolves around application management and testing, which can involve unit testing, functional integration, runtime performance. These are your main tests, and there's other tests involved too, but these are your main ones. Then you're going to, in the data science life cycle, we focus a lot on your business requirements gathering. So this is talking to stakeholders, trying to solve problems. And then you have your feature engineering and your hypothesis testing. And then your machine learning model lifecycle, which is the ML/MLC. And this is going to refer to now your automated training, your production deployments, specifically your model production deployments, your model monitoring, and then also model version. Now, where they overlap is in the circles, as you can see right here in this Venn diagram. You're going to have production maintenance as part of your software development life cycle and your machine learning model life cycle. And then for the intersection between data science and software development life cycles, you're going to have the iterative business focus, because in software, you have to focus on how the business is going to be affected. And then you have between your data science and machine learning model life cycle, you're going to have model development. As I mentioned, there might be some experimentation and collaboration in your model development. So you might have to do a loop-in, depending, of course, on what you're monitoring and depending on your validations. Now, the real cross in between, again, there's a lot of other things as well. It's not an exhaustive list, but what's common among all three of these life cycles is really the fact that you can program it, that you can actually monitor things. And the programming languages are going to be different, of course, across the three different software development life cycle. Might involve maybe something different like Java, say, for example, or Scala related. Data science life cycle might refer to maybe like Python or R as your main ones. Then the machine learning model life cycle couldn't be any of those languages I just mentioned. But you also can do some pretty interesting things in just pure JavaScript, depending on your model architecture. And so again, the one common denominator across all three is that you can program your ideas. So these are three different life cycles. I'm bringing these out for a reason, and that's because when we think about model deployments, sometimes we go into the data science life cycle and start trying to add that as part of the requirements, when in reality, that's just more the beginning stage for the machine learning model lifecycle. Now, how we manage that, we're going to talk about that more in detail. So our main focus is going to be the machine learning model lifecycle. The other components here are important and needed for any project end to end, but we're just going to focus on the last points right here. So this is going to come in now to our serving diagnostic deployments. So there's normally two approaches. The first approach is actually the REST API approach. And so here that could involve a web server. Normally it does. And so this is the pros and cons. The pros of following this approach of a web server that is really easy to deploy. You can deploy manually, not using Docker, but there's a lot of Docker images available that allows you to deploy using Docker in a number of very scalable application management systems and services, and specifically within a cloud. You can build microservices everywhere that anyone within the organization can use, as long as you have, of course, access to that network. And as I mentioned, it's easy to scale because you can send batches of information or a single record of information to get prediction. And then you can have your web server scale those requests so that you can go and essentially make sure you can scale to the data size that you have, which is a normal problem within the whole data and AI realm. Now, the con, and this is really more related to how you do things. And one of the cons is, unless you have any middleware to manage requests and tag predictions, maybe to unique identifiers, if you want that level of granularity and tagging, it's going to be difficult to measure model drift. So as I mentioned before, there was aspects of model development, deployments, and monitoring. So when you're monitoring how effective your model is and whether your model predictions and recommendations and inferences is degrading over time, because it's possible for a model to degrade over time. So if you don't have a means to measure that, then you don't have a means to measure the value your model is giving back to the company. Another con is overloading the host web server. It's very easy to do that if you don't have a load balancer in place. You can have 1 million requests coming in to a very small machine that used to maybe handle only 1,000 in one sitting, and that could overload the server and crash it. And so you want to be very careful with that. This is an example diagram where you have a client request, you have your web server, a middleware web server that may change the data a little bit, send it over to the ML web server and send it back. And so this is something that is a common pattern. You don't sometimes need the middleware server if you're doing a pure custom web server with Docker, but this is a pattern that you normally would see here. Then we have the application approach. The application approach, it's very easy to customize your inference step with the overall process. You have full flexibility with the post-processing. It's easy to then start extending a current applications and packages, especially the big data processing packages. Now the cons, the maintenance of this is similar to anything you would do in software development, and there can be a lot of overhead if not managed properly. And then depending on the model, it's actually very difficult to scale. And so this again all comes down to scaling and making sure you have each record, each inference for your data. Now you have your application approach. Again, this is an example. You have your input sources, processing your features, preparing them, creating your predictions, and sending to output source. And there's a lot of tools you can use. You have Kubeflow, Airflow. You have your data storage types between NoSQL, SQL, object storage. You have your different computes, which could be cluster or single instance, and you have your serving data source, which could be, again, NoSQL or cache. Those are the main preferences there. Now we're going to have a couple of case studies here. One is actually dealing with Levi's supply management optimizations. And here we use Docker, Apache Airflow, and AWS, and Apache Spark for big data loads. So essentially we have a data extraction, your feature engineering, but then also your model deployment aspect. And there the model is deployed within a Docker setup deployed onto AWS ECS cluster. So essentially just a compute cluster. And there that enables us to process our information, send it over to the machine learning model, and then send that to another data source, which then a web API can pick up. And then we also have Nielsen media data. I was part of the data integration team for some time. And so there we focus on Dockerizing an ML application, which I manage directly. We also orchestrated our tasks using Airflow. We use AWS as the main cloud provider. We use Apache Spark for all of our big data loads, more specific towards our feature engineering. And then we use data lake formations to make sure that the data that we're producing, the features that we're producing, actually then is mirrored and replicated very easy and easily taggable across time. The difference between these two here, of course, besides the company, is the Dockerization and also data lake formations. The Nielsen media data, we had a history, and that was developed very easily within the data lake perspective of things. Now, this is another service I built, and this is more on my own, more or less, but this actually right here all pertains to deploying an ML model into a REST API. So the first two right here were all batch-oriented, running on some type of daily cadence. But here, this is a little different. And this is where the REST API aspect that I mentioned earlier, and that was used. And so here, this is actually the Docker and TensorFlow serving for the pure model serving that sits behind a load balancer, which, as I mentioned, that's one of the things you might want to do. And then in the front end, you have your Docker and some type of client-facing application. Now, this could all be different between the use cases. But this was used here along with Nginx for proper request load balancing. And so these are the three main services. Each of them are all different with the models underneath. This is using time series forecasting. This is basically using nearest neighbors variant, and this is essentially a deep learning model. But no matter what the model that was used under the hood, by following these approaches, the REST API and application approach, you can have a truly scalable and optimized model. Thank you.
Wow, Edward, thank you so much. That was incredible. And I know this virtual audience is giving you a huge virtual round of applause. Thank you again for sharing with us today. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.